Welcome to another lecture on numerical analysis. In this lecture, we will study Newton's backward differentiation method. In our last lecture, we studied Newton's forward differentiation method. This method, Newton's backward differentiation method, is used when we have to evaluate the derivative of a function near the end of the table. And the method we studied last time, Newton's forward method, it is used when we have to evaluate the derivative near the beginning of the table. Right, so we'll solve the same example we studied in our last lecture for Newton's forward differentiation method, that is x squared plus 4x is the f of x given, and its first derivative is 2x plus 4, and we are going to evaluate it at x is equal to 1 near the end of the table, and it gives us f prime 1. The derivative of f computed at 1 is 6. So next we are going to apply Newton's backward differentiation method, and we'll verify this answer. We'll try to reach to this answer 6 using Newton's backward differentiation method, the iterative method, the numerical method. In fact, the numerical method. Right. So using this numerical method, we'll have to first make a table. The table is the same as we did make for Newton's backward interpolation method. This is the same table. We have nabla here, and this nabla y is computed as this y minus this y by n plus 1 minus y, and same del squared y, nabla squared y is computed as this minus this minus this, and nabla cube y is this minus this and this minus this. Right. So the same way we developed this table when we studied Newton's backward interpolation method. The same table. Right. Next we are going to apply a very simple formula to compute the derivative using Newton's backward differentiation method. So it involves nabla squared y, nabla cube y, nabla 4y, etc., and 1 over d, where d is the difference between the values of x, assuming to be constant, to be having constant intervals. So the interval is 0.25 in this case. So this is 1 over 0.25. Nabla y is 1.44. So how do you select the values of nabla y, nabla squared y, nabla cube y? From the x, we'll first move horizontally to y, and then we'll move diagonally up, like we did for Newton's backward interpolation method. From x, we go straight to y horizontally, and then we move diagonally upwards to find the values of nabla y, nabla squared y, nabla cube y, etc. Right. So the nabla y is 1.44 plus 1 by 2 nabla squared y is 0.13 plus 1 by 4 nabla squared y along the diagonal is 0. Right. So when we evaluate it, it comes out to be 6, and the conclusion is that we reach to the same answer. Which answer? This numerical answer, this exact analytical answer. So using this numerical technique given by Newton, we reach to the same answer. Right. That's all for this lecture. We'll keep on studying more about numerical analysis in our next lectures. Thank you.